problem here, did I? I'm getting lost between the two classes because you guys are ahead of them. Okay. That's two-stage amplifier. You got a PMOS in the front, NMOS in the second, and here's the specs for PMOS and NMOS. And we're supposed to calculate everything, and let's call this as 1 and 2. 1 and 2. So before you go anywhere, you must calculate the DC conditions, right? Before you can calculate the gain, because you need the value of G sub M. Now, looking at this, what's this voltage? This is VG. VG1, what is this voltage?
2.5.
2.5.
No, see, here,
Oh, we don't know that. Oh, 0.5.
minus 5 on the bottom. What is it? 0, right? Looking at it is symmetry. If you're not, you can calculate the gain and you go from one node to the down or now one node up. 0 volt. What's the equation for 1? For 1 is ISD. Not the S. It's equal to KP VSG minus VTP absolute value squared. I will give you those equations on the test.
Thank you.
All right? Now, what did I tell you to solve for? Current or volts? Volts. Don't solve for current because you could make a mistake. You can solve for current. All right? Now, we need that value in terms of VSG. We have VG. VG is equal to 0. What's VS? Here's S. Where's the arrow is, right? It'll be 5 minus ISD times 2K, right? 5 minus ISD 2K. Now, what am I looking for?
ISD.
VSG, right?
Oh.
So VSG then is equal to what? 5 minus ISD times 2K, correct? So ISD then is equal to 5 minus VSG over 2K. That's equal to this, KP 0.25 VSG minus the absolute value of minus 1 squared. Right? So there'd be 5 minus VSG, 2 times this is 0.5, okay? VSG squared minus 2 VSG plus 1, right? I could multiply the left and right by 2 to get rid of things. So we have 10 minus 2 VSG is equal to VSG squared minus 2 VSG plus 1. I just multiplied by 2 to get rid of this 0.5. Right? we're gonna have VSG squared. It's gonna be minus 9 equals 0. And this is 2 VSG minus, oh,
You cancel out.
that's it, right?
So VSG equals 9.
So
or square root of 9.
VSG equal plus or minus 3. Right? So what's the answer?
Plus 3.
Plus 3, right? I sub ST then is equal to 5 minus, what is it? 3 divided by 2K, lo and behold, 1 million. I told you I made these problems too. I'm working backward. All right. That's 1 million. So you could calculate the Q point if you wish. What's the Q point? Q1. Q1 is VSD ISD. So this is equal 1 milliamp. And what's the voltage here? What's VS? Big guy. What's VS? What's this voltage?
5 and the teacher.
The current, what's the current? We already calculated the current, 1 milliamp, right?
Yeah.
5 minus 2 times 1 milliamp, what's
It'll
the?
be 2 volts.
3 volts.
3 volts.
3.
5 minus 2.
3.
Yeah, 3 volts.
Okay. What's VS? I mean, yeah, what's
VD.
VD?
2 volts.
Minus 5
Minus 2.
plus 1
3.
times 3 is minus 2. So what's this?
5 volts. 5 volts.
5 volts. Right? Now you have this voltage. Minus 2 volts. Now you can go to calculate this current. All right? So for the second one, we have now IDS is equal to Kn VGS minus VTN squared IDS. So we're gonna find it in terms of VGS. So we have VG is equal to minus 2 volt. What's VS?
Plus 3.
I'm sorry?
Plus 3. Plus 3 volts.
What's? You're okay? What's V sub S? IDS 2K minus 5 rising by that, right? Minus 5 plus IDS. It's better to call it I1 and I2 probably instead of, but you have to make sure. Times 2K. So I'm looking for VGS in this situation. So VGS is equal to minus 2 minus 5 plus IDS times 2K. And this will be plus, so it will be 3. Minus 2 plus 5 is 3. Minus IDS times 2K. That's equal to VGS. So IDS is equal to what? 3 minus VGS over 2K. Correct? And that's equal to Kn. Kn is 4 milliamp over whole squared. VGS minus 0.5 volt squared. So you're gonna have 3 minus VGS, it'll be 8 times VGS squared. Now minus VGS times, this is 2 minus 4 would be minus 8 VGS, right? And this is 0.25 times 4 is 1 minus 2. Now, what that gives me, 8 VGS squared minus 7 VGS. No, this would be plus 9. No, this is minus 7. Minus what, 5 equals 0 with these factors. It's 5 and 1, 4 and 2 maybe, I don't know. Does it factor? We only have this. So I need a minus, more minus than plus. What is this? 4, 20.
Is it plus 2?
Is it 4 and 2?
Is it supposed to be plus 2 at the end of the, after you've squared it? After you squared the VGS minus 0.5, is it supposed to be plus 2?
This is plus 2, that makes it a little easier.
Yes.
Plus 2
Minus 1.
will be minus 1, so that has to be plus or minus 1, right? Now what do we do? 8 and 8 and 1, right? So where's the 8 goes?
On the negative side.
On the negative.
Or,
To the right one. So
8
where is it?
VGS, right?
It goes on the other side.
the other side. The 8 goes on the right side, so multiplied by the negative 1.
8 VGS, VGS. Now gives me what? 1 volt. The other one is negative.
Positive.
That's nice. The way I work them out, they're factorable with that calculator. All right, so what's ID? IDS is equal to what? Where is it?
Okay.
3 minus 1 divided by 2K. Beautiful. 1 milliamp. Okay. So now we have 1 milliamp here, and we have 1 milliamp here. Okay, what's the Q point? Q2. 1 milliamp. It's 5 minus 1. What's the voltage here? If this is 1 milliamp, this is minus
Negative
5.
3.
This will be minus 3, right?
Mhm.
5 minus 3 is 2 volt. No, 5 minus
Plus.
minus 3 is 8 volt. Now, to calculate the gain,
So you have two.
you need G sub M1 and G sub M2. You follow? Big guy, you follow?
The only parts I'm kinda lost on is when you had the, equation.
The equations, I'm gonna give you the equation.
No, I'm saying like when you start plugging it in for,
Yeah, this is a algebra.
no, not the actual math itself. Like, when you were doing the node, did you just go from, to the BJT downward to -5 and make that a KVL?
Yeah, see, if if you wanna find this voltage, how do you do that? Forget the current now, to forget that you know the value. What is this voltage? It's Vs, right?
Yeah.
Okay, this is Vs. What is it equal to? You have to find ground, voltage, somewhere to start with KVL, right?
Yeah.
You're starting here as -5. So -5, is this a rise or fall to get to here? If the current goes this way,
It's a rise, so it's negative.
it's a rise, right? This is higher than that,
Yeah.
correct? Because the current going this way, so the voltage drop from there to there. So it'll be plus ID. Right?
Yeah.
If you don't see that, you could look at it like this. That's the same voltage there, right?
Yeah.
Do KVL. Minus V plus I times 2K minus V equals 0, right?
Yeah.
So, okay, so you bring the V to this side, V is equal to -5 plus I. That's basic analysis from circuit 1, right? Okay. Now, what do I need before I can calculate the gain? Small signal, and I need the values of G sub M. Okay? What's the value of G sub M1? G sub M1 is a P channel, right? What did I tell you? I will give you the equation. What is the derivative of dI dVGS, right? That's G sub M. That's input impedance. I over VGS, the input voltage. So the I, the VSG in this case. Oh God.
You know you love them.
And if you take a look here, it's 2Kp VSG minus the absolute values of VTP. That's the derivative. Kp is 2, Kp I believe is 0.25. VSG, what did we calculate VSG?
3 volts.
3 volt. 3 minus the absolute value of VTP minus 1. Milliamp per volt. Okay? Now the GM2 I need, it's going to be 2Kn VGS minus VTN. 2 times 8 milliamp, 4 volt squared. VGS, for 2 it was 1, right? And what's VT? 0.5. So it's 4 milliamp. That's it. Right? Now we have to calculate gain by drawing the small signal equivalent circuit. Let's do that here. Take a look at the front. You have drain, source, and gate here. Right? What do you have at the input? At the gate you have 25K K, and V in. That's on the left side. And this is a P channel, right? Where's the source? What the source is doing? Look at the picture. Look at the picture. What do you do to the DC value? Oh, you got a capacitor there. Shorts it, right? So this is a ground. And this is VSG. Because that's a P channel. VSG. And right here you'll have GM1 VSG, and which way the direction? From source to drain. Source to drain. Look at the picture, the arrow. All right, that. And then what do you have? You have 2K to 3K to ground, right? 3K to ground, and that puts you at the gate of 2. Source of 2. This is now VGS. Yeah, VGS. And here is going to have G sub M2, VGS. Where's the drain goes to? Look at the picture.
Down.
Ground. And what do you have here? Resistor to ground. What's the value of that resistor? 2K in parallel with 2K. 1K. And this is V out. You follow the picture?
Yeah.
Okay, now we gotta calculate V out over V in. I could see V out is related to VGS, right? I could write it in terms of VGS. So this is V out over VGS. Then I could write the VGS in terms of VSG. So VGS in terms of VSG. Here it gets confusing. I'd rather put 1 and 2. This way I don't get confused. And VSG in terms of VN. Okay? This one is the easiest. What is that value?
25 times.
Minus 1. See? This is positive this way. It's minus 1, right? There's a ground here, and it's reverse polarity. So this is minus 1. What's the value of this? Of this one, the first one. V out, this is 1K to VGS. And let's call it 2, 1, so I know which one I'm talking about. Right? What's this value?
GM1 times 1.
Positive, right?
Positive.
GM1 times 1K. That's the tough one. I'm gonna leave it. This is VGS, so that's 2. I'm gonna call 1 here, so. No. No, that's GM, this is GM2, right?
Yeah.
Okay. VGS is 2, okay, and this is 1. So I'm gonna look for that ratio. That's the tough one. Because there's impedance deflection involved here, without knowing. I could write, okay, which one and 2? This one 1, this one 2, right? Right?
Mhm.
This is gate of 2. Hold on,
It's the same.
both 2. This is 2. Right? There's the one here. Right? Okay. Let's take a look at VG2. What is VG2? Right there. G sub M1
S2.
times
Is S2
3K VGS1, right?
Is S2 connected to ground?
All the voltages are referred to ground. VG2 is referred to ground.
Okay,
It's voltage division.
yeah,
I mean, Ohm's law.
yeah, so VG.
This current times 3K.
Oh, yeah, for VG2, yeah. not-
Okay, that's VG2. How about VS2? This is VS2, right? What is it?
Same as
G
VG.
in time.
G sub M2
VGS2.
VGS2 times 1K. Right? Take this, I'm looking for VSG. What am I looking for? VSG or VGS? VGS and,
Oh, it should be VSG1 at the top, 3K VSG1.
this should be VSG. Okay? Maybe better to, I don't know, you got to keep track of them. If sometimes you maybe put a P and N this way. All right. Now, I want this ratio 2 to 1.
Let's go subtract.
There's 1 and there's the 2s. Let's take a difference here. Which one I should take? I'm looking for
G2 minus S2.
VGS2, VGS2, so I'll take the difference. So VGS2 minus this, I'm gonna take the top one, G sub M1, 3K, VGS1, right? Minus what? G sub M2, VGS2 times 1K, right? And let's regroup them. This is VGS2, I can bring to this side, I'm gonna get VGS2. I'm gonna get 1 plus G sub M2 times 1K equal G sub M1 3K VSG1. So I'm looking for a ratio 2 over 1. So I'm gonna have VGS2 over VGS2, okay, or over VSG1, and that would be what? G sub M3K, G sub M1, 3K divided by 1 plus G sub M2 times 2K. I mean, let's calculate that value. We have G1 to G2, we got the G's. G1 is 1 milliamp and G2 is 4 milliamp. So that'll be 3 divided by 1 plus 4, 0.6. So what goes here, 0.6. And then GM2, what goes here is 4. Okay. 4, and the gain is minus 3.2. I think. Unless we made an error someplace. I think the answer is in here. Let me see. If it's not 3.2, I'm not gonna look.
It's a similar problem as 3.2, yeah.
It's in there, someplace. 12/5. What's that?
Minus 12 over 5. That's the same.
Is that 3.2?
No, it's not.
Someplace. I screwed up someplace.
It's like 2.4.
But look, I got one over here. It's in there, okay?
Yes.
But they understand the mechanism, right? All right. I have no idea where the error here.
So I think you did it right.
Just
Huh?
the other side.
You did it right.
You have the wrong side.
I did it right, why is the answer not right? Or unless I multiplied the last
Yeah,
answer.
it was just multiplying, but it's 4 times 0.6, which is 2.4.
Oh, yeah. So 4 times 3. How much is that?
Then minus 2.4. So you got.
Why do I get 3.2?
I don't know.
Which is 12/5.
Yeah.
Oh, there's no error. I just made the last error, but according to TA, you lose 50% of your problem.
What?
Yeah. Yeah.
Because you didn't get the right answer.
Yep.
They must be digital people, either 0 or 1.
Yeah, no.
You did all this work, okay? You got the wrong answer or the wrong sign.
Imagine.
My apologies, I don't know what else to tell you. I'm trying to, you have to try to average in the grader
Inaccuracy.
capacity. I don't know how to do that. Other than you complaining to them and get it corrected. If you don't, then
Multiple
Anyway.
choice at the end.
minus 2.4, that's the right answer.
Oh. You roll the dice, you might get 100. They should just make a final, actually build the circuit. Does it work?
Sound better. Really better.
I hear. What's his name?
Who?
Wow, Dong, what's his name? The one that teaches circuits. He's going to teach electronics too with the EPOC.
Dong? The new guy?
Oh, no, he's not. There's only one section of electronics too.
Yeah, sadly. I think he's talking about Dong. I'm sure he's talking about.
This looks like a weird problem,
You guys don't.
but it's not.
Rigid but approachable? He's really fast talking. Yeah. Yeah. I'm gonna record his lectures and watch him like half speak.
redraw this problem actually. This drone's crazy. You can redraw this problem, right? Let's redraw it, so you recognize it.
Turn aside.
Okay, let's do this. Now here's the source. Here's the gate, look at the gate,
This
this
goes to
ground,
ground.
Oh, you're getting wood.
okay? And the drain is, oh, 5K here. There's a 5K to 5 volt there. And on the drain, there is a capacitor and there's a 4K. Right? And the source, you get 10K. Here's -5. And right here, you're gonna get V in, right? Just redrawing it. That's the same circuit. Okay. They're ignoring again RO. Which one do you like to solve, the top or the bottom?
The same.
Bottom one's better.
The bottom looks easier. Look where the
This
input,
looks more clean.
where's the input voltage is on the source.
Yeah.
Okay. What kind of configuration this is?
NMOS? NMOS?
You said
Huh?
something.
NMOS.
Common gate.
Yeah, that's in MOS. What configuration
Oh.
amplifier this is?
Common gate.
Common what?
Common gate.
Common gate. It's ground, right? Okay, the equation for this is BS, I guess. K VGS minus VT squared, so this would be K. 3 milliamp per volt squared. VGS minus VT minus 1 squared. And I told you, let's write this in terms of VGS, right? VG is ground, let's see. VG is ground, V sub S is equal to 1. Minus 5 plus current times 10K, right? Correct? So this would be VGS would be plus 5, minus ID times 10K, right? Okay, I'm just taking the minus, yeah. So then I sub D is equal to 5 minus VGS divided by 10K. So it'll be 5 minus VGS divided by 10K. Right? So this will give you 30 times VGS squared minus 2 VGS plus 1, and this is 5 minus VGS, so there'll be 30 VGS squared minus 2 VGS, 2 times, oh my God, is that right?
Mm-hmm.
Yeah, because the 10K. That would be 60 minus 60 plus 1, right? Minus 59 VGS then we'll have 30 minus 5 plus 25 equals 0. Can you factor that one? I bet you can.
Probably. Take a while.
1 and 30.
If 5 times
No,
5, and I need 30.
I don't think so. That's not factorable.
I don't know. Let's get the answer, okay?
Quadratic formula.
VG, no, you cannot factor it. VGS 1.35 volt. Let's see if that fits that equation. 161.35 squared. Yeah, probably. You guys know how to use the calculator. All right, then if you calculate ID, it's equal to 5 minus 1.35 divided by 10K, and that gives you 0.365, that's not my doing. 0.635 milliamp, and you can go ahead and calculate G sub n to get out of it. The 2 times K, K is 3, VGS 1.35 minus 1 and 0.35, 0.65 times 3, oh boy. 2.086, 2.9, 2.09. Okay? Now, let's draw the small signal. Gate, source, drain. Let's take a look at the gate. Gate is ground. And this is, by the way, VGS. Now here's the source. From the drain to the source, you have this. G sub M, VGS. And you have the output on the drain, which is 4K in parallel with 5K. And right here, you have resistor, 10K to ground. And here is VN. Right? Well, that shouldn't be difficult to do, right? Vn equal to Vs. Okay? Right? Okay. So, here's V out. So V out over Vn is equal to V out over VGS times VGS over Vn. What's V out over VGS? G sub n times 0.8, 20 divided by 9, right?
Would it be minus,
Parallel combination
would it be minus G minus G?
minus, I use one ratio. What's VGS? 0. What's V sub S?
Oh,
Huh? equal to Vn, right? V sub S is equal to Vn. Right? You got it? Vg is 0 minus Vs, which is Vs equal to Vn. So it'll be Vn over Vn minus 1. So it'll get plus G sub m 20 over 9. And what's G sub m? Did we calculate? 2.09 times 20 over 9. This is a 1 point something. This is 2.3, 2.4. Okay. Which one is easier, MOSFET or bipolar?
I like BJTs, they're pretty cool.
BJT is
MOSFET.
easier. But you don't have the quadratic equation to deal with.
Well, the end part, I think MOSFETs are easier.
Yeah, quadratics.
This
Just
part
plug it in.
MOSFETs are easy. At the end, when you have to set the ratios equal to each other, but the beginning part is BJT.
BJT, you have that convenience of impedance reflection
Yeah.
when you have that little resistor dangling. In here, it's an impedance reflection, but it's easier the way I've taught you to
Yeah.
calculate one and take the difference and then regroup them left to right. That would be easier than impedance reflection, because you could have done right here, Vn, look at Vn. What's Vn equal to? By the way, the 10K didn't play a role, right? Right? Okay. Look, if Vn equal to the minus of that. We're almost done. I'd like to do next time bipolar and MOSFET together. Oh no, there's one MOSFET there that has that impedance thing, and then bipolar MOSFET. And congratulations, we are done. Almost done. Any questions? I am gonna send the DA an email when I get home for them to finish the grading as soon as possible, and hopefully by Wednesday, tomorrow or Thursday. And I'm gonna add the inspection of your circuit for next Tuesday between 11 and 1. All right? And the report is due next week, right? When is it due? On Monday?
Tuesday, fifth.
Tuesday, so the report, and you can do the inspection on the hours he did already, if you don't want to wait that long and get it over with. So you could concentrate on writing the report, but there will be that, and the test is on Thursday the 14th. At
Awesome.
10 o'clock. I prefer to be 2 hours. I don't want to give you more than 3 problems. Typical test is just, but it counts 25% of the grade.
Yes.
All right? And for the grading of 2, there will be a multiplier, 1.2. So that's already agreed on. All right. Any questions? Yes.
Will the quiz have any BJTs on it, or is it just MOSFETs?
This time? No, only MOSFET.
2.5.
Is it gonna double count like you had mentioned, or not?
What do you mean double count?
You said it was
I was gonna also add a quiz next Tuesday
Okay.
for MOSFET quiz, just a wrap up.
So what are we expecting the difference between the quiz this Thursday and next Tuesday?
Different problem.
But same sort of material.
That's right, different problem. It could be one common base, could be something else, you know. It's just, I wanna get the 8 points, the 8 quizzes, yes.
Oh, so for quiz 6, I took the quiz in person, but I didn't upload.
I may have to do 2 quizzes next Thursday, one for the 11 o'clock session and one for the 1 o'clock session. So I don't force you to come during an hour that is not scheduled.
Yeah.
See what I mean? I don't wanna deviate from your schedule. But the fact I could do the testing for the circuit, because you have other options,
That's
all
true.
right? All right, yes.
But yeah, I took the quiz on quiz 6, but I didn't upload the documents, so it's like missing.
You got what?
The
Couple of,
quiz-
what's
It
missing?
was a quiz 6, yeah, because I didn't upload a little screenshot. But I took the
Scan.
quiz that day.
They should have the physical paper, talk to TA.
You have submitted a hard copy?
Yeah, we take the
Yeah.
hard copy, but I didn't submit the screenshot thing.
Well, if they don't grade you correctly, you go show them the hard copy that,
Yeah,
that you gave them. Yeah, that's no
Exactly.
problem. That's why
yeah, I need to talk about.
that's why I
Chris
picked the
Lee.
hard copy, because I've had problems in the past. People forgetting part of the test
Yeah.
or not uploading correctly or something.
Yeah.
But we have hard copy who can go back. Steve, I gotta get him to grade your test as well. I have it in my office.
Okay, thank you.
All right.